All right, welcome everybody to another installment of our Open Game Data Open Office Hours. And so for anybody who might be new either to the recording or to the session, just want to reiterate some of and reintroduce kind of what we do here. So the Open Game Data Community is a NSF-funded research incubator trying to bring together a collective of researchers that are interested in using data that's generated from within and around games to advance our scientific understanding of thinking, learning, decision-making, things that humans do. And we have two primary goals. One is to compile a set of resources and best practices and sort of convene this community, and these open office hours are one of the ways we do that. And then also our long-term goal is going to be to build tangible research infrastructure that helps us actually do this kind of stuff and this kind of work together. We have a bunch of resources already. So the Open Game Data website is hosted at Field Day Games from the University of Wisconsin-Madison. And has a bunch of resources, has a bunch of examples of games that are sharing data and people are playing. And then we also have a Slack channel that we use to coordinate and talk to each other and share ideas and resources. And then we have these open office hour sessions, which like the one we're doing today, where people share and talk about the work they're doing, and we hear about cool stuff going on. So a brief primer on how these sessions work. So they're inspired by a series of sessions that the Statistical Education Research Group used to do at Carnegie Mellon, where somebody would come and share a project they're working on. It was usually a student or a postdoc. And they would essentially workshop with one of the people in the stats faculty. And they would kind of be like, this is what I'm trying to do. Here's what I've tried so far. Here's all my R code. Here's what I think it means. And they would just publicly workshop and get advice and feedback and thinking. And it was a really valuable resource to be in that audience and then just kind of watch how do experts think about their problems and how do they kind of do this work. And so we're trying to sort of model that same idea, but centering it around game data, then not necessarily specifically statistics, and provide this kind of platform for people to talk about their work and also see how people think about their work. Some quick things to keep in mind. Presenters are often showing work that is in progress, so please keep in mind that that can take some courage. Some things aren't always necessarily done or polished or ready, and there might still be some next steps to be had. Our goal here is really to help the presenter kind of understand their work and help them achieve their goals. But also these sessions are intended to be a venue for learning for all. So if somebody mentions a thing that you don't quite understand or you want to ask for clarification, feel free to raise a hand. Or if you have any feedback or advice for the presenter, feel free to also chime in on that. And with that, I will hand off to Luc to introduce. You can introduce yourself, your work, everything.
Thank you. All right, let me share my screen and get things started. So you should be able to see the presentation now. Good, okay. All right, well, thank you so much for inviting me. So for those of you who don't know me, my name is Luc Paquette. I'm an associate professor at the University of Illinois, Urbana-Champaign in the College of Education, and I do a lot of work around educational data mining, learning analytics, basically trying to look at log trace data of how students interact with digital learning environments, and that includes games, although it's not exclusively about games, and then trying to make sense of kind of how the process of how the students engage with those learning environments and what does that tell us and how can we use this in a meaningful way. And so today what I'm going to be talking about is one specific project that we're working on, which is around investigating the development of STEM interest in WHIMC. And WHIMC is a Minecraft-based learning platform using machine learning and detector-driven interviews. So before I get things started, I do want to say that this is a team effort, even though I am the one presenting. So there's a lot of people that have been involved in some way in this project. I hope I didn't forget anyone. I probably did. And I do see that some of them are in the call right now. So Jacqueline, Jeff, Rachel, Sophie are here, and they might be able to answer some questions. They might be able to give some more context about this work. Yeah, just as Eric was mentioning, this is work in progress. We're really definitely open to like suggestion, feedback, discussions about this. So feel free to interrupt me, to put things in the chat. I put some things in the slide if we don't get through everything because there's discussion. I think that's fine. I'll try to get through everything, but even if we don't reach the end, I think that's fine. So before I get started talking about this specific project, I want to talk a little bit about the context, which is this WHIMC platform. And so WHIMC stands for What If Hypothetical Implementations in Minecraft. And so what the WHIMC platform or learning space is not this project. So this project takes advantage of the existing platform. So it was developed by one of our co-PI, Dr. H. Chad Lane, and his colleagues. And the goal was to develop computer simulations that are designed to engage, excite, and generate interest in science. And so they decided to do this in Minecraft because it's an environment that is very well known, very popular, that kids are generally interested in. And they want to and it's also designed to be very kind of open-ended exploration. And so it aligned very well with their goal of taking the kids, putting them in those virtual worlds and having them explore the world and try to kind of understand that world. And so the reason why it's called What If Hypothetical Implementation is because at least part of the worlds that the kids are going to be exploring are those what if alternative Earth questions. So for example, you might have a world where the Earth has no moon, and then so that has implications about what they see in the world, and they need to explore, they need to make observation and try to understand what is different between that hypothetical world and kind of the regular Earth as we know it. And so this is the context, right? And so the work that we're trying to do is to go into this environment and try to improve our understanding of how the learners engage with those simulation in WHIMC, what kind of behavior they show, but also more specifically, how do those behavior might relate to their STEM interest, right? How does participating in those worlds trigger interest in STEM in some way, or fails to trigger interest in STEM in some way? And so what we want to do, right, is we want to use a combination of both data-driven log trace analysis and more qualitative interviewing. So the idea here is that the log trace data is really good at informing us about what is happening, right? We have those very detailed logs of the student did this, the student did this, the student did this. What they're not good at is telling us why the student is doing this, right? And so we might compute things from the log data and say, like, we think this is related to interest, but unless we actually go and collect more information, we might not know why this might be related to interest. And so to complement the log trace analysis, we want to do interviews. The idea is that we want to go in the classroom. Actually, this time it's usually summer camps. We want to go into summer camps and actually talk to the students in real time to understand their interaction with the game, how that relates to what they find interesting. And we want to do it in a way that is informed by the log trace data. And so this is kind of generally what we are aiming to do, right? So for this presentation specifically, the project was started in July 2023, or at least it was funded in July 2023. Always takes a while to get things really started. So we're still pretty early in the work. And so what I'm going to present today is describe some of the ongoing work that's around understanding how learners interact with WHIMC and exploring ways that we can extract meaningful behaviors from the log data. But this is in preparation of actually going and conducting those in-situ interviews in order to better understand how the Minecraft learning space foster interest in STEM. And this is more specifically about astronomy. So with that in mind, I think it makes sense to talk a little bit more about WHIMC, the kind of activities that kids do in WHIMC, to give you some context in terms of thinking about how do we actually work with this data, right? So WHIMC is something that usually takes place in camps, usually summer camps, although there's been also after school camps or things like that. It's usually over a week-long camps, although again, sometimes it's shorter. It's very flexible, which is something that is really interesting, but also makes working with the data much more complicated. And it's composed of different types of activities. So usually the kids are going to be put in Minecraft world and they're going to explore the world, and then they're going to maybe have a guiding question that they're going to try to understand, and then they're going to interact with the world in different ways. And so there's different types of worlds, right? There's some of those hypothetical Earth worlds, right? What if the Earth had no moon? Or what if it had two moons? Or what if it was more tilted? Or something like that. In addition to that, there's exoplanets that are just completely different from Earth that they might go and explore as well. And then usually at the end of the camp, there's an activity that's usually is over multiple days where they go and they have a world that's like Mars, and they have to build an habitat that is suitable for living on Mars. And then in addition to that, there is out of Minecraft activities and discussions, right? So it's not like the kids are put in Minecraft for a whole week and they just work in Minecraft. It's usually like they work a little bit in Minecraft, then there's some discussion outside of Minecraft, then they go back to Minecraft, there's some discussion outside of Minecraft. So usually when they go to Minecraft, and Jeff can correct me if I'm wrong, he's our WHIMC expert on the team, they usually spend like between 20 to 30 minutes in Minecraft, and then they jump, do something else, and then come back to Minecraft and they explore the worlds, right? And so for the context of this project, we're mostly going to be focusing for now on the exploration worlds, right? Those what if hypothetical Earths and those exoplanets. We're also interested in the Mars habitat building activity, but we haven't looked at it yet because our expectation is it's what we're going to be paying attention to in that world is going to be much different than what we actually are paying attention to in the exploration world, right? The exploration world is more like you have a world, you go out, you collect data, you collect information, and then you try to understand it. And so in those worlds, the kids are not allowed to build, for example, right? They can't modify the world in any way compared to the Mars habitat building world, where the whole point is that they are building something. So the type of interactions are going to be very different. So for now, we only focused on the exploration worlds. So a couple of like key things that kids can do in those exploration worlds. So there's points of interest. There might be building, there might be like museums, there might be like NPCs in the world, there might be like geographical features that are of interest. And so one of the expectation is that as they are exploring, they would encounter those different points of interest, or they might see one in the distance and then go towards it, and then they would interact with them in some way. As they're exploring the world, they also have access to science tools that they can use to make measurement. And so this is not something that they would usually have in Minecraft, but at any moment they can open the chat and then enter a command in the chat to make a measurement. So for example, I don't know if you can read the figure here, it's a little bit small, but basically here it's an example of someone made a measurement about the speed of the wind. And I think, again, I'm going to try not to say the wrong thing here because I'm not the WHIMC expert, but for example, in the world where the Earth has no moon, one of the impact of that is that the wind speed would be higher. And so they might be able to go in the world and make that observation. And then because the wind speed is higher, that has an impact on the vegetation. So the trees are going to look different. So then they can kind of try to tie that together. And so at any moment, they can go and do those science tools to collect information. And then they can also enter observations into the world. So similarly, they can pull up the Minecraft chat and enter an observation that's going to be kind of verbalizing or communicating something that they see, something that they're curious about the world. And then once they do an observation, that observation is in the world. So anyone that walks near it can read it. And so it's kind of a way also to communicate information to other people on the server through those observations. Right? And so those are kind of actions that are specific to WHIMC that they can do, but generally, they'll also just walk around and explore, right? And so because of that, the data that is being collected and the tasks are very open-ended, right? And so one thing that is really difficult then is to make sense of like, okay, in terms of how they interact with the world, how is it based on like the design of the game inform their interest in STEM? Or how maybe if they come in with a preconceived notion of Minecraft, pre-existing interest in Minecraft, how does that change how they behave in the world? How does that change the way that they get maybe interested in STEM or not, right? But because it's very open-ended, kind of what I was saying earlier is we can't just go and do log data analysis and try to make that relationship. We need to go deeper than this. And this is where the interviews are going to, I think, be very informative, right? To try to link that kind of exploration that they do with what we're interested in, which is interest. I will say the word interest way too many times in that presentation for different meanings. Hopefully it's still going to be clear. And so one of the issue though with conducting interviews is when do you actually conduct the interviews, right? Who do you interview at which moment? And so in order to help us with that, we designed this tool called Quick Red Fox, or QRF. which is based on this idea that those in situ, like in the moment interviews can be really helpful in giving us rich information about why the students engage in certain behavior. But in order to know like when is the best time for us to interview, it's difficult. If you're thinking about like a room with 10, 15 kids in the room, you have maybe 2 people doing interviews. You could interview everyone like in order, but then you might, that doesn't mean that you're going to be interviewing them at a time where there's something interesting going on. Or you could look over their shoulder and say like, oh, this is interesting, I'm going to go and interview, but then you might be missing something that's happening on a different screen. And so we designed this tool to try to help us with collecting more targeted interviews. And this is a tool that was originally developed in the context of a different project, studying self-regulated learning and affect in a different learning environment called Betty's Brain. And so the idea behind QRF, or Quick Red Fox, is the following, right? So we have the learning environment. And so the learning environment will connect to the Quick Red Fox kind of infrastructure, their server. And then it's going to monitor in real time the learner behaviors of students based on their log trace data. When in the learning environment, something happens that we think is meaningful, then the learning environment is going to communicate this to the Quick Red Fox server. The Quick Red Fox server receives that, and then as a way of prioritizing different events based on, we can kind of adjust that as needed. And then it's going to select one of them to say, you should collect more information about this. And then it's going to send that to an application. I don't know if you're going to be able to see it, but we have this phone-based application that connects to the Quick Red Fox server. And so the Quick Red Fox server is going to send a request to an interviewer to say, you should go and interview the student because this is happening. And then at that point, the interviewer can decide to say, I'm going to interview the person, or I don't want to bother that person at this moment, so I'm just going to skip it. If they decide to interview, then they can record the interview directly on the phone. And then when they're done, they click a button, it notifies the server that the interview is done, and then the server picks a new interview for the researcher. And so the goal here is to maximize the time where the researcher is actually conducting interview, but without, just like flooding the researcher with requests for interview, right? And so in terms of what the application might look like, and again, I know the text here is very small, so I'm going to explain a little bit what this is. And this is an older version of the app, but it still has the same information. But the idea here is that at the top here, you would have kind of more like information about which student you should go interview, why you should go interview that student. Then here you have a space where you can just enter textual notes. And then you have a button here that is start recording. So then once you click that, it's going to pick up on the microphone, and then you can do the interview. When you're done, you do stop recording. And then when you're done entering your note and everything, then you just click next. And then that records the information. It synchronizes it with what events triggered this interview so that we can do the mapping later with the log data. And then it just selects a new interview. At any moment, again, the interviewer can just decide to skip if they think it's not, because one of the things we don't want to necessarily also be invasive of the student, right? So it's important to be able to have that flexibility. Eric, yes, go ahead.
Yeah, so just for some clarification, when you say interview here, like how in-depth of an interview is this? Is this more like a verbal one question thing, or is it sometimes a whole protocol, or?
Yeah, I think it's going to be a little bit flexible. It's not going to be a super in-depth interview, right? It's going to be like, and Jacqueline is in here, and so I might ask her to fill in as well. She's the one that does most of the interview. It's going to be like a couple minutes, maybe. It might be like an initial like opening question with a few follow-up. Jacqueline, I don't know if you want to jump
Yeah,
in.
no, it's usually 3 to 5 minutes. And we usually start by saying, hey, is it okay for me to talk to you? The kids in the project where we've run this before were using Betty's Brain. Most of them did not really look away from their screen. And I go in with a fairly newscasty looking microphone just because the directionality in a noisy classroom is a really helpful tool. And so, before we get started, we sort of make a big deal. You don't have to talk to us. You can talk to us. And our approach for the Betty's Brain project was to always start with, hey, what are you up to? What's your strategy? because it's a nice open-ended thing. And then we kind of let the students lead from there. We were there for 2 weeks, one in December and then another in February. So we were able to make some modifications to those interviews as we saw themes emerge. So as it became clear that we had very anxious students, we started asking questions that might approach that, as it looked like, intrinsic interest was motivating some behaviors. Then I tried to work in questions like, hey, what do you want to be when you grow up? That, are normal kid questions, but would allow us to kind of get at things that were constructs of interest.
Cool.
Yes, Elizabeth is asking, how do we prioritize behavior? So a lot of the prioritization is kind of decided by us before we go into the data collection. So when we send the message to the QRF server, we send also a numerical priority. And then that's kind of the first thing that's going to be considered is the numerical priority. There's behaviors that we're really like, they might be really rare and we want to capture them when they are happening. And there's some things that are like, if we have nothing else to talk about, then we can go and look at that. And then on top of that, we have another system for prioritizing different students, right? So that we're not going to talk to the same student over and over and over again and always bother them. And also so that we have diversity in the response. So it's kind of a mix of those two things.
Yeah, and there's one other question, I guess, about the quick red box system. Do you take into account, like, do you try to estimate interruptibility as much as you estimate, like you do some kind of detector, I assume, happens, and it's like, behavior happened, we want to hear about it. Do you also try to balance, like, an interesting behavior happened, but also it's like a very cognitively intense behavior, and so maybe we want to wait a beat before we go and interview, or do you just assume that happens in the logistics of the room? Or
that's a good question. I think we haven't really had a situation where that was a factor. I think there's two places where I would see that happening. One is in terms of deciding when to interview, right? And so if we know that something is really intense and we only want to talk to the student after they're done, we could design the trigger so that it gets sent to the server after it's done rather than when it's ongoing. So that would be one thing we could do. And then the second thing is the interviewer always has the option of saying, I don't want to interview right now. So if they look at the student and they see the student is really focused and they don't want to interrupt them, then they would just skip it, or maybe they would wait until they see that the student is kind of more receptive to an interview before going to talk to them. On top of that, there's a system, I don't remember the exact threshold, but there's a system in the server that if a trigger has been there for too long, it gets removed, right? So because at some point, if you don't want to go back and interview something that happened 10 minutes ago, right? Probably less than 10 minutes. But so we have like a threshold that like we don't want to interview on things that are too old either.
We also throttle on when was the last time this kid was interviewed, so that we're not interrupting too frequently.
Yeah. All right, I'm going to keep going, but feel free to interrupt me anytime. So yeah, so this is kind of the system, right? And so then the question becomes, how do we actually find those interview triggers? We want to go and we want to interview. How do we actually get to those triggers that we think are going to be meaningful, right? So we want to use the log data collected by WHIMC. And we want, ideally, to trigger on things that should capture interest or lack of interest or something related to that, right? And so then it becomes a question of like, okay, what does the data that is actually being collected in a WHIMC looks like, and how do we manage to work with it? And so WHIMC is collecting log data from their camps. And fortunately for us, while our project is early, WHIMC has been running for multiple years. And so they already have historical log data that we can kind of dig into to try to start working on identifying those triggers. And so that's going to include information about, the WHIMC specific action, using science tool, making observations. But there's a lot of things that happens outside of those WHIMC specific actions. And really, the big majority of the data is location data, right? Every 3 seconds, there's an entry in the log data that's like, this student is at this X, Y, and Z coordinate. And then, so this is the data that we're working with, right? And so we need to figure out, how do we work with this very unstructured data? There's a couple of things that are very specific, right? The student made an observation. But if you're looking at the location data, this is very unstructured, right? That's just like, here's where the student is at any given moment. So the students are free to explore however they want. They're going to be provided with some guidance, and there's going to be facilitators that are going to go around answer questions, but really they're kind of put in this world and they can just move around as they want. And so it can be difficult to identify what are the things that are meaningful in there. And to understand why the kids are engaging in those behavior. And that's where the interviews we think is going to be especially meaningful. And so in terms of the first thing that we did is we need to understand what it means for someone to interact with WHIMC. And so we have a few people on our team that are WHIMC expert, right? Jeff, for example, has been working with WHIMC for a lot of time, but the people that are doing the log data analysis are all WHIMC, newbie, right? They haven't really been in the WHIMC camp. They've never been in WHIMC before this project. And so the first thing is we really wanted to make sure that we add a sense of like, what does it mean to interact with WHIMC? What does it mean to be in one of those WHIMC worlds? So we had some people from our group just jump into the WHIMC server and just kind of play around with it. Like, what are the things that I can do? How would I go and actually go through this world myself? How would I engage with it? What would that look like? But we're not the actual people that are in the camp. So the way that we're going to be interacting with WHIMC is going to be very different. And so we add some screen captures of kids using WHIMC. And so that's also one thing we did is we actually watched video recording of the kids playing WHIMC to get a sense of like, okay, how did they actually interact with the world? What are the things that we see in there that we think are meaningful, that we would like to be able to get from the log data? And then that gave us some idea of, here's a couple of things that we could try to compute from the log data. And then based on our understanding of what the kids do in WHIMC, and based on our understanding of the log data, and I will say both of those things are constantly evolving. And so what we understood about the log data and how the kids are playing around in WHIMC at the beginning and how we understand it now is different. And probably in 2 weeks, it's going to be different again. Because WHIMC is really designed as a way that the kids engage with this in a very natural way. It's not like you need to go and you need to do this. I mean, they have tasks, but it's not like an interjump tutor, for example, right? Or it's not even like a game that you can win. And so we always learn like, oh, actually in this world, this is happening. In this world, this is happening. So which one of those do we think we can extract from the log data? And then try to think about like which one we think is going to be easiest to extract from the log data, and which one of those do we think is actually going to be important, for what we're trying to do. And so what I want to kind of do next is just give a sample of some of the stuff that we've been looking at and kind of explain some of the things we've seen, and also kind of how that's our conceptualization maybe of things, of like what we expected we would do going in and how that changed. So I'm going to not give an exhaustive list of the features that we compute, but I'm going to show a few ones, right? And so the first thing is the observation and the science tool use, right? So those are things that are really specific to WHIMC. And there are things that are really like specific action by the learner to try to engage with WHIMC, to try to collect information about the world, to communicate that information about the world. So we thought this is going to be really important for us. We really want to get information about those. And so if we look at science tool use, for example, right, we would say, okay, do they even use this? When do they use it? How often do they use it? In what context do they use it? And then the idea here is that meaningful use of those tools should hopefully reflect some engagement and some interest in the task, at least, if not in science. But then not using the tool might be the opposite, right? A lack of engagement, of interest. One of the things that's tricky is that because they don't do something doesn't mean they're not doing something else that's meaningful. So you can't necessarily just make like a one-on-one, like using the tool is good, using the tool is bad. They could also be misusing the tool by just like spanning the tool. And then like, this is not a meaningful engagement as well. So a lot of the features that we're going to be looking at have this kind of weird distribution of like, never doing it is probably not good. Doing it too much is probably bad. Probably somewhere in the middle, if you're using it in a meaningful way, it tells us about your engagement and your interest. Although the extreme values are also interesting for us because we want to understand why the students engage or don't engage in those types of behavior. And so if we're looking don't be scared by the next slide. It's a big table, lots of number. I'm going to talk a little bit about this. We're not going to look at everything, but the idea is that we start by just looking at the distribution of how often do they even use those tools. And then on the left side, you have all the names of all the different tools they can use. As you can see, there's a lot of them, and not all of them are going to be meaningful for all the worlds. And so it's really dependent on the world, which tool they might use. Completely on the right, the last two columns are actually correlation with measures of interest that have been collected in the past. So the first of those two columns is interest in Minecraft, and then the second one is interest in astronomy. And so the idea here was we wanted to get at least a little bit of a sense of like, does that seem like it's maybe related to interest? But because we're doing so many correlations, and because we only have 90 students, this is not like reliable necessarily, right? This is more for us as an indication of like, is this something that is worth looking into or not, rather than for us to make generalizable conclusion about the relationship between tool use and interest. And so one column that I want to highlight is this one here. So this mean column is the average number of time that a student uses a given tool. And so what you can see here is that the numbers are actually not very high, right? And this is related to different factors, right? Each tool has a very specific purpose. A tool might be useful in one specific world, but not in the other worlds. And then even the tools that are more general, like temperature, you can see that they might use it like 5 times on average, because it doesn't really make sense to use it too much in the same world. Or actually, temperature is one of those that could actually change between different location in the world, but some of them are always going to be the same. Like gravity is always going to be the same no matter where you are in the world. And then if you look at the last one at the bottom, right, here, that's across all tools. So on average, a student will use a tool around 20 times in a week. And so if you're thinking about 10 worlds that they're going to be exploring throughout the weeks, that means about 2 times per world they might use a tool. And then if you're thinking about exploration, maybe for 20 minutes per world, that means they're going to use a tool about once every 10 minutes. And so while it is interesting for us when the student used the tool, it's not that common, right? And so it's good that we have this detector to try to identify when it happens, but also we can't just rely on tool use. We need to think about other things that are of interest. And then the same thing for the observations, right? Are they making observations? How often? When? But then in addition to that, for the observations, it comes with text, right? So the learner writes something in observation. So we've also had people try to look at what kind of text do they put in there? What purpose does the text serve? And so we've been trying to figure out if we can do some kind of coding on the observation to give us a sense of how the student is interacting with the world. And so on the right side here, I've put some examples of codes, things like social interactions, right? They can leave each other a message through those observations. They can ask questions, they can seek help, sometimes it's just related to game literacy, right? Something that they like about the game that they've observed and they just put it there. And so not everything is going to be an observation that's related to the science, but all of those things could be interesting for us to learn about. And then we have a similar table that I'm not going to spend too much time on, but similar table for observation in terms of the frequency. This time, observation is just observation. It's not different tools. So what you have on the left is the different worlds. And so how many times do they make an observation in different worlds? And again, you see kind of a similar pattern of there's a couple of worlds where they make a lot of observations. But then in most worlds, they do it on average, less than 2 observations per world. And then on average, they maybe do 2 observations per world. And so again, it's something that's going to happen maybe like once every 10 minutes. And so we want to know when that happens. We want to learn about this, but also we need something else, right? Otherwise, we're just going to be waiting for things to happen for a very long time. And so the main source of data really is the location data. But the location data is also the one that's the most difficult to work with, right? Because it's just a set of coordinates. So how do you make sense of that? So we try to figure out how we can try to make sense of those coordinates. So a couple of things that we tried is I mentioned there's regions and points of interest, right? So we had someone actually go into the worlds and try to map the coordinates of every regions and points of interest. And then once we have that, then now when we have location data for a student, we can say, is this within any of the points of interest, or is it close to an NPC or something like that? And then that is useful for us because then we can say things like stopping and revisiting a point of interest, right? So does the learner just walk through a point of interest without stopping, or do they actually stop there? How much time do they spend? How often do they stop in a point of interest? Do they come back to some of the points of interest that they've already visited, right? And that might be useful to know, right? Someone that comes back, there might be a reason, or someone that just jumped in and out of a point of interest, but never actually stops in it, right? So those are things that could be interesting for us to learn about. We've also added, and I'm going a little bit fast over those, stop me if I'm going too fast. I also want to be mindful of the time, so we have time for more discussion. One other thing we were looking at is spatial coverage, right? How much of the map are they actually exploring? And not just the spatial coverage as a number, but also as how it evolves over time, right? You're probably going to see like period of like the student is exploring or moving between point of interest, and then there might be a plateau where they're kind of within one region for a longer period of time, and then they might start exploring again, or they might revisit points that they've already explored. So that would also be a plateau where it doesn't really go up much because they've already been here. And those are things that we haven't really figured out how to use them yet, to be quite honest, but things that we've kind of explored a little bit, right? So you can see some example of trajectory of spatial coverage for different students here. And then the other thing that we're interested in doing with the location data is related to learner proximity, because there's multiple learners in the same world at the same time. So if we look at their coordinates, we can see how far from each other they are. And that might be indicative of some social interactions that happen between the students, whether it's social interactions because they're working together or playing together and ignoring the task. So that's something that we might want to know, right? So we looked at, for example, are learners spending extended amount of time near each other. So here I have a figure that's just like the distribution. Every time that we've identified that two learners were in close proximity to each other, which is defined as like a distance of 35 in the world, which is what we estimate is, far enough that they can still see each other. Beyond that, they probably can't see each other. And so here you can see that most time it's on the left side, which means they don't necessarily spend a lot of time together. But you can see that there's a couple of cases where it's on the opposite side, where they actually spend between 3 to 4 minutes in close proximity to each other. And that might be interesting for us to learn about this. What is happening? Why are they working together? Or why are they close to each other? And then on the opposite spectrum of that, we have cases where students that are not close to anyone for an extended period of time. And so that might also be interesting. What does that mean, right? If they're not close to everyone, that means they're kind of doing their own thing. Why is that happening? And a lot of those we don't really know, right? And this is kind of, I think, where the interview process comes into play. So those are things that we can compute from the log data, that we've been computing from the log data, but then we need to move from computing those to actually deciding when we're going to go and interview the students, right? So those are numerical value most of the time. And so how do we transform that into triggers for the interviews? And so what we've been exploring, and we don't know if those are the right approach, we're going to kind of figure it out as we actually do the work, is things like identifying outliers in the data, right? Someone that spends an expected amount of time in a region of interest. They've been in this region of interest for 10 minutes. What is going on? Or, two learners spending a long amount of time near each other. Someone that's never visited a point of interest. We want to know why this is the case, right? And then the other thing, as we're working with the data, we're realizing is that what is an outlier or what is a behavior of interest might actually change from one world to the next, even though they all have the same basic structure of like, those are the things you can do. The design of the world is going to influence how students interact with that world. Some worlds are really tiny. Everyone is close to each other. And some worlds are larger, right? And then there's more opportunity to be far from each other. Some worlds have a lot of points of interest. Some worlds don't have points of interest. And so depending on the world, it's going to impact how the learners interact with it. And we might need to kind of think about how we're going to decide on triggers based on the world. And then where we are right now is in actually going and implementing the trigger so that we can do the interview in real time. So we started working on this. I'm not going to go into too much detail of this, but this is kind of the workflow. Basically, WHIMC updates their database in real time, and then we have a Python script that's going to pull data every 5 seconds. That's going to look at what the student are doing and then push that to the QRF server. And so the part that's really missing right now is this 5-second script that actually decides the trigger. And then what is upcoming is we are probably going to be doing, unless something terrible happens, a pilot study in mid-April. So that's in like 3 weeks now, where it's going to be 1 week, 2 camps, half-day camps, one in the morning, one in the afternoon, where we're planning on having about 10 learners per camps. And the goal really is just like making sure the infrastructure is actually working. We can actually get the trigger, we can actually do the interview, identify everything that's going to go wrong, because I'm sure things are going to go wrong, so that we can anticipate that for the next time, get a sense of if we have even the right triggers for the interview, and get a sense of how to conduct interview, get a sense of what we're missing, with the plan of doing kind of a larger, more official data collection in the summer, where we're still planning everything, but the goal is to do 3 week-long camps in the summer, and then where we would use what we've learned from the pilot study to go and kind of, collect more like, I don't want to say better data, because I think we're going to get really good data from the pilot study as well, but just maybe more targeted data. And so this is kind of what's upcoming, right? And yeah, that's all I had. Thank you so much, everyone. I know there's a lot of stuff. I tried to go a little bit quick, so let me know if you have questions, follow-ups.
All right, thank you, Luc. If anybody has any questions, feel free to raise a hand. Can call you out. I have a question. So you mentioned that you're concerned that you might need to retune these detectors for every level.
Mm-hmm.
Do you think you might also need to retune them for every population? Like if a particular class works together, like maybe 2 kids are friends and they follow each other everywhere, or maybe there's other social dynamics that are going to be part of like, am I a loner or not?
Yeah, that's a good question. I mean, we know from past experience in WHIMC that the different camps are going to have very different dynamics. So we know that for sure, that some camps, the kids are really engaged and really like on task. And then some camps, the kids are there because they have to be there and they're just kind of not as engaged. And so I think it's an interesting question of, does that mean that the trigger needs to be different? Or does that mean that we reuse the same trigger, but not the same thing are going to pop up? And we're not going to do the same interview. But I think once we do a first round, we'll get a better sense of like, for this group, what happened? For this group, what happened? And then I think that's going to go and inform us, right? The plan, if everything goes according to plan, is we're doing 1 data collection this summer, then we're analyzing the data, and then we're going back into the camp the following summer to do follow-ups. And so I think there's a lot of things we're going to learn this summer that's going to be like, here's everything we did wrong. Here's everything that we need to do. Yes, the kids, different population of kids don't play around in this environment the same way at all. And our detectors are fine-tuned for this population, and we missed so many things for that population. I think it's definitely a risk, and then I'm going to be curious to see what happens. We're trying, to build triggers that are as general as possible, but that's always what happens, right? One of the things that we're planning is to have like a fail-safe of like, if there's no trigger, just go interview a random kid.
Mm-hmm. I actually kind of wonder if I don't know if there could be like a comparison condition, or like what if the whole thing was just randomly sampling and then you were correlating interviews to log data as opposed to trying to do these targeted interviews off of the detector.
Yeah, I mean, that's a good idea as well. I think well, I don't know. We might have some of that naturally. One of my concern right now is that a lot of the triggers that we're thinking about are things that are like behavior that happens too often, like more or like takes longer to happen than expected or things like that. And my worry is that the triggers are all going to be like towards the end rather than towards the beginning. And so we might actually end up having a lot of random interview at the beginning. It's not quite the same, right? But that might tell us a little bit of that dynamic between like randomly triggering interview versus actually doing an interview that is targeted. I think it's a really interesting question. It's not necessarily the goal right now, but I think this is kind of a new approach to collecting data. We've used it in the past once, but it's still very much experimental, right? We don't really have, like, if you ask us like, what is the best way of doing this? It's like, well, here's what we've tried so far, but there might be a better way of doing it. And it would be interesting to do that kind of study. It's not necessarily the plan for this, but it would be interesting.
Liz has a question in the chat. How might this process influence gameplay?
Yeah, that's a good question. So I think it will influence gameplay in some way. And again, Jacqueline can jump in and fill in. She has more experience being in the classroom. She tries to be as little invasive as possible, but if you're going to talk to someone, you're going to influence their gameplay. One of the things we've observed in Betty's brain, it seemed like there was an effect where the interviews were actually resulting in students showing more self-regulation in their work, just from the fact that they were being interviewed about self-regulation. So they ended up like kind of carrying that in the learning environment beyond the interview. And so there is a little bit of an interview effect for sure. We don't really know how that's going to show up here. Jacqueline, I don't know if you have.
I was going to say, I think it might have been Yingman's paper that looked at, maybe it was Nigel's that looked at
It was Nigel.
Self-reflection in the interviews. And, you know, to some degree, because we didn't go up and say, hey, why are you bored? You know, the triggers in Betty's brain were half of them were affective. And that just didn't seem like a productive way to talk to children. So and, you know, in some ways for them, for their experience, it was sort of like a random interview. Even though, you know, it wasn't necessarily for us. So I think there's a lot of questions to that because, you know, definitely if you look through the literature, and there's a huge literature on interview approaches, and, you know, if you don't ask questions, there's some data you're not likely to get. You know, and which was why with the last project, we started to adapt the interview strategies to try to, you know, see if, okay, it's not just the anxious students who are reporting their anxiety, but can we get the kids who aren't anxious to talk about not being anxious? And that sort of thing. So
yeah, I think maybe the other thing to add is that there is facilitators in the room normally that will go and talk to the kids. So we're hoping that while it's going to be different, it's not going to be that, you know, foreign, because there would be facilitator in the room that would be going around and talking to the kids and helping them normally. And we're just adding one person that goes and do interview. But it's still going to be different because, you know, they're going to come in with a microphone. But Jacqueline usually tries to position herself as like someone that is like, just you're helping us rather than like we're trying to collect data from you to kind of get them to open up and interact with us. And
I tell people my goal is friendly older sister. Like, I'm not gonna let you beat the crap out of your neighbor, but I'm not here to bust you on not doing your homework, right? So like, I'm not part of the team, the developers. I'm really curious about you, and just really try to keep it not big brothery, and very, very friendly and non-authoritative.
Jimmy?
Yes, so thank you for your presentation. And I have a question about the triggering behavior. Like, first of all, are they just single behaviors or single actions like open an observer or open another term you used before, or is like a kind of combination of this behavior?
Yeah. And this is really up to us. How do we want to approach it, right? So we could be like, this is one specific thing, one specific action that is really important. And if it happens, just let us know. Or it could be a lot of our feature, I think, are going to be like looking at behavior over time and then identifying a moment where we're saying like, at this point, you really should have done an observation. You haven't done any observation. We're curious about that. Or looking at you know, patterns of navigation of the world over time. It's like, oh, you've been close to each other for a while. let's go and talk and see what's happening. And then on other side of this, you could even have even further, we don't have that yet, but you could build like classification models, like really complicated models to identify behaviors. And then that could be running in the background. And then once we identify that behavior, then we send the request for an interview. And so the grain size of what we're going to be using to trigger the interview is really up to us in terms of what we think is going to be the most interesting. For now, the ones that we have has been mostly kind of looking at over time, if there's something unusual, like something that lasts for a long duration or something that happens very frequently, more than we would expect. And so it's not like a single action, but it's also not on the opposite side of like doing like, you know, a deep learning model that detects a very specific thing and then but we could do that. The system allows you to do it. That's not the approach we've done here yet. If we do once we do the Mars habitat, so one of the things that the WHIMC team has been working on is they've tried to build this deep learning model that can assess the quality of the habitat across different dimensions, right? So they have different dimensions of like, if you're going to be building on Mars, you need to consider those different things. And so they have tried to build a deep learning model that takes data about, you know, the building interactions that the students are doing, and also takes a picture of the habitat and then provides some information about like across different dimensions, like this habitat is scored at this on this dimension. And so if we go into those worlds, one thing we were thinking about doing is periodically running those deep learning models to get assessment on the different dimension, and then looking at changes over time on those dimensions. And so in that case, we would be using like a really complex model to drive the interviews.
I see. Okay, thank you. So one follow-up question for that is that, like, I think it's like, I'm not sure whether I get it correctly, but is this like a crowd of people, crowd of students playing the game at the same time, or they do it one by one?
Yes, so the servers are actually publicly open. I think like anyone can join at any time, but this is more specifically in the context of like a camp where there's like, I don't know, 10 to 15 students in the camp, and they all jump into the same world at the same time. And then they work on that world, and then they might go and do some activity outside of Minecraft, and they come back at the same time in a different world, and then they interact with each other.
Yeah, so if so, like, what if like multiple students express like similar behavior that need to trigger the interview, and do they need to wait for the interview one by one, or like?
Yeah, so there's a system to try to prioritize which interview we're going to do. So there's the server will receive all the requests, and then there's some prioritization that's going to happen. One of the things that we're doing is just, you know, this specific behavior is high priority for us. This specific behavior is like, we're interested, but only if nothing else is happening. On top of that, we have different students. So we want to make sure that we interview different students. And then on top of that, I think we might also have, I don't remember if we have that one or not. I know we've talked about it at some point, is getting some diversity of behavior to interview, right? So that we're not always going and interviewing the same behavior. And so if the same behavior happens for multiple students all at once, what would end up happening probably is one of those students would get picked to do the interview for that behavior based on whether we've interviewed that student before or not. And then Jacqueline is usually the one that's interviewing, but Jacqueline might notice if a group of students are actually working together on this. And then when she interviews, she might change the dynamic of the interview to incorporate that in some way. And she'll probably put a note in the text field in the interview, like this was group behavior with this student, so that we can then go back and look at the data and see like, actually, while we interviewed that one specific student, this was actually kind of something that was kind of more broadly applicable to different students at this time.
Gotcha, guys. Thank you very much.
So kind of just following up on that a little bit, does the system like show a queue to the interviewer? So like if there are multiple and you're like, oh, they're all working together and I'm just closer to this one, so I'll go with them even though they're not the first one?
Not right now. You could open the server and look at the queue in the server, but in the moment, the interviewer really only sees one request at a time. And Jacqueline, I don't know what your thoughts are on this. My guess is that the interviewer is not going to have the mental bandwidth to deal with that, but
No, I was just trying not to fall over while I was crouching down talking to kids most of the time. So, fewer decisions are better, I think, in those moments. And that, also, like I said, unless the kid is really not interested in talking to us, or in one case with Betty's brain, we were in a regular classroom, so there was a kid that had his head down crying for the whole week, and I'm not going to get, that child is on his own. Like, I'm not going to try to make any more trouble for that child. So, but otherwise we do want to make sure that we are hitting, the distribution of students, and I don't know that I would want to mess with that system and oversample because this one looked more interesting and miss something else that we hadn't hit, because I'm not going to be able to keep track of how many things, even how many triggers we've had of a given thing. I think when we piloted this the first time, and this was not the studies that we published because we managed to break everything, including the router in the classroom. But you can tell, like, if the prioritization algorithms have been screwed up. We had one team that programmed 1 to 10, where 1 was the priority and the other one went the other direction. Things were going poorly. We could, you can have an intuitive sense of that, but trying to keep track of 30 kids times 10 triggers times 20 prompts is a lot. So I think it's probably better not to go that route, even if I were smarter and better balanced. So
Sure. So I do want to be conscious of time for people. We are technically at the hour. I don't know, Luke, if you're available to stick around for a few more minutes or not, but just want to remind people. But thank you for coming. Anybody who has to have seen a few people head out already, but we do these every other week, and actually the next session will be Isadora talking about Calypso, which is a cybersecurity practices game. But if anybody wants to keep hanging out, I will keep the Zoom live as people are available.
Well, thank you for having me. And thank you for everyone else on the team that also was here. Thank you, Jeff. I know I didn't acknowledge, but all the kind of context information in the chat.
Yeah, thanks for sharing everything. I was kind of curious a little bit, if you have the time, about the kind of camps these are. Are they like, is it, so just reflecting, we recently published a paper on some work we did doing co-design with kids in a bunch of different after school programs, and kind of realizing there's like various categories of them. And so it's like, if it was like a STEM enrichment program versus it was like a safe space versus it was like a rec center, and you get completely different kid play behavior in those.
I'm going to let Jeff answer that question. He's our expert on camps. I think there's a lot of diversity.
Yeah, and actually the WHIMC grant that led into this, the idea there was some interest triggers in different contexts. So we intentionally partnered with different planetariums. And so that was the context where, you have kids that are in a planetarium camp, they're probably into astronomy, right? So that's very much in your favor. But on the swing side of this, like, we have partners in Illinois, the one that we've been working with for a long time, where it's just like, that's their standard summer camp. They have, like, a whole giant summer camp. The kids are there all summer, and this is just one of the programs that's happening throughout the summer. And they have some ability to opt in and out of stuff, but it's like limited. It's a choice among several things, and they got to be there one way or another at the camp. And then those kids may not have any interest in astronomy. And the demographics will also swing wildly. So like here in Colorado, it's like mostly like white kids that are super privileged, whereas the ones in Illinois have been kids who like might not know what astronomy is, and are like, they're coming from schooling backgrounds where they're really underserved, and it's mostly like kids of color. So it's a pretty wide range. We've also done some intentional recruiting. So like one of my favorite camps is where we took a giant wait list and we made sure it was an even count of boys and girls. And that camp looked super different than So there's the demographic things, and then there's the context of the camps. We've done some where it's like installments, like one a week over the course of like after school. And then we've done some stuff actually even in school where like we knock out like a lunch period and another period, and then they run a camp or run through the camp then. So it's, and I could tell you details in all of them, but yeah, it's definitely varied in what it looks like.
Mm-hmm. So I could definitely see that being a variable that you would want to be considering in tuning the different detectors and behaviors and stuff.
Yes.
Yeah.
Yeah, and somebody was asking earlier about the kids playing alone versus together. Well, this actually began like with COVID in the middle of it. So like it was actually really beneficial that we had these all remote like learner sessions. Like it was designed where you could play solo. We actually had with partners in Ateneo, there were kids like all in a class, but they were all playing remote because that was what you were doing in that moment with COVID. So we had sort of that hybrid-ish thing. And then we've actually, I think even had one where there were some kids in person and some remote as well. So it's been like, and that's kind of the danger of this too, is that makes the data really complicated depending on how far back you're looking at and what you're looking at. But it also shows the versatility of the system, and like, you know, it means that we could apply it in different, circumstances. So
Totally.
it's neat.
Cool. Any other questions, Luke? I'll do Luke.
Yeah, I don't think I've got any questions right now.
All right. Well, great hearing from you, and definitely love to keep in touch as we keep moving this open game data thing forward and seeing ways we can learn from each other's work.
Yeah, that sounds great. Yeah, thank you so much for having me.
Totally. Right.
Thanks everybody. Good job, Luke.
See y'all.
See you.